laws. So you all should have familiarity with these 3 laws. I'm not going to ask you to state them in exam, but you're going to have to use them to solve questions, right? Very important. So let's go back to the notes on eClassroom. Right, so what I'm interested in doing at this point is using the rules of logs, right? So I'm interested here in the same document, you see where you have using logarithms to solve equations. I'm interested in this now, right? So please follow with me. Some of these here may seem complicated if you're not being careful, right? So I will do, let me see how many questions are there. I have some other problems as well. Right, so look at this, guys. Let's do this as an example first. So we are looking at section 12 in the set of notes that's here, using logarithms to solve equations. And the example that they have is 3 to the power x is equal to 5. So let me take you to the whiteboard and explain, right? So look carefully on the whiteboard. It's not difficult, but you need to always remember your rules of logs in your mind while you're working the question. So the exercise we have is to solve. So we have to solve the first one, 3 to the power x is equal to 5. Let me make sure you can see the whiteboard, right? So follow me. So apply, the first thing you do in this type of question is you apply your rule of logs, right? So you take logs of both sides, right? Taking logs of both sides of the equation, it looks like this. So log, you just write log to the 3, x is equal to log of 5, right? You all know when you have an equation, when you impose a change on one side, you must impose exactly the same change on the opposite side. An equation always must be in a state of balance. So here I'm using the rules of logs, right? If you don't remember, I'm putting a circle there to show you. So we're going to use your rule of logs here. What does the rule say? Rule 2. We're going to use rule 2. What is rule 2 above say? You put the power in the front, so we'll get x log 3. Right? So let me stick that into the question. So I'll get x log 3 is equal to log 5. And all I have to do now, guys, is this. All I have to do is solve for x. How do I solve for x? This means x times log 3. So if I take the log 3 in the opposite side, I'll get x is equal to log 5 over log 3. All you do is you take your calculator, you press the word log, press log 5 divided by log 3, and you'll get your answer in decimals. Round it off to 2 decimal places, and you are finished. Right? Any questions there? Anybody?
I'm saying it over that one more time, please.
Which part is giving you trouble?
After you no, I understand from where you put the exponents in front according to the rule.
Right.
So right, yeah, right after the x log 3 equals to log 5.
So all I'm doing here is I'm multiplying, right? What does x log 3 mean? It means I'm multiplying x by log 3. So if I want to solve for x, I make x the subject of the formula. Remember, there will be a multiply here. So if I take log 3 on the opposite side, instead of multiply by log 3, I'll now have to divide by log 3. And that's how I got that. All that's left for you to do is take your calculator, press log 5, divide button, log 3, get an answer, round it off to 2 decimal places, and you're finished.
Thank you, sir.
Any further questions? Yeah, someone has a question.
Yes, sir. I just wanna make sure. So the reason why you're changing it from the log form is because you can't solve it in the form that it is right now, which is the
No.
log 3. So you
It
have to change the form.
Yeah, that's exactly it. What's your first name again?
Adenike.
And Danny, that's exactly why. As it wasn't 3 to the x is equal to 5, I could not solve it. So I have to use logs to solve it. So I dedicated the nail on the head there. That's exactly why we use logs. Any further questions, anyone? I'm not rushing you. And if you all have questions, please ask.
So we do questions using the other laws as well, just to see the difference.
Of course, we're going to use all the laws and questions, Lydia.
Okay. Thank you.
Right, so that was just one example. We're going to increase the complexity a little bit just now. So here's what I want you all to do. Right, I'm starting with baby steps before we actually get into bigger type questions, right? More challenging ones. I want to make sure you all understand the baby step ones first. So here's what I want you all to do. Right, I'm not rushing you all at all. I want you all to, right, look at your screen. Look at your screen, everybody. I want you to solve number 4, parts A and E, right? Do that now. Number 4, A and E, right? A as in apple and E as in egg. Solve them now. Similar to what I just did, right? So you're doing A and E. I'll give you 5 minutes. Go ahead.
sir, do you have to state which rule you're applying, or you would just see it based on the weekend?
No, you don't need to state the rule. You could just, I usually state the rule because you all are new to it, but if you don't want to state it, that's fine.
Okay.
All right, so I'm going to correct it now, part E and part E. Ten to the power x is equal to 5, and 4 to the power x is equal to 12. Right, so let's do them. So here I'll get, if I take logs on both sides, I'll get log of 10 to the x is equal to log 5. And using the rule of logs now, I'll get x log 10 is equal to log 5. And then finally, I'll get x is equal to log 5 over log 10. And as I said, you could get that in your calculator. Press log 5, get an answer. Press log 10, get another answer, and just divide them. And this one now, I'll get log 4 to the x is equal to log of 12. And then using the rule of logs, I'll get x log 4 is log 12. So x will be log 12 on log 4. Again, use your calculator and you can get your final answer there. Did you all get that?
Yes, sir.
Yes, sir.
Okay, great. Anyone has any questions on these two before we move on?
No, sir.
Okay. All right, so I'm going to move on to something a little more challenging, right? So I want you all to keep working with me, right? I don't want you to get lost. So we're going to increase the complexity now.
Sir, given what we just did, we did 4A. I see 4B. Or is that what you're about to do?
4B, let me see. Okay, so 4B, anything that has E in them, I'll talk about E afterwards. E is a special type of log, a special type of function. And I will discuss all the rules. Well, not all, there's not much, there's one additional rule. So I will talk about that in about, how long? In about 30 minutes from now, and we'll come back to B. Right, so look at this example now. 3 to the power x is equal to 5 to the power x minus 2. We're going to try to solve questions like this now. All right, so let's look at this, everybody. All right, so pay attention to this. Right, so look everybody, look at this. I'm going to write down rule by rule, step by step what I'm doing, and I'll give you one to try. Right, so the first thing you do in a question like this is you apply your logs, or you could say taking logs on both sides, right? So you'll get this log log 3 to the x is equal to log 5 to the x minus 2. I took logs of both sides. Next, I'm going to apply my rules of logs. Right, that will be x log 3 is equal to x minus 2. Remember, this is my power here, times log 5. See what I got? Any questions so far? Take a moment, see if you have questions before I move on.
No question.
No questions? Okay. So what you do now is this. You're going to try to simplify both sides. Right? So when you have x minus 2 log 5, you multiply everything inside a bracket, or each of the terms inside a bracket, by log 5. So let's do that now. You'll get what? X times log 5 is x log 5. Minus 2 by log 5 is minus 2 log 5. Right? You all okay with that so far? See if you have any questions there. I just removed the bracket there. What I'm doing now, I'm bringing all the terms with x on the same side. So I'm bringing this term on this side. So I'll get x log 3 minus x log 5 is equal to minus 2 log 5. Right, any questions?
Not yet.
The second to last thing I'm doing now is I'm seeing x here and I'm seeing x here as well. Let's factorize out the x, right? Because it's common in the two terms. So I'll get x times log 3 minus x times log 5. I factored it out, is equal to minus 2 log 5. And the last line now is this. I'm multiplying x by all of this here. So if you're multiplying, when you take this across now, you must divide. You all know that. So you'll get what? You'll get x by itself on the left. And you'll get minus 2 log 5. Minus 2 log 5 over log 3 minus log 5, and you're finished. You're finished. Any questions? Let me give you one to try now to convince yourselves that you all are okay. If you have problems, of course, I'm here to help you, right? So let me write a question for you. I want you all now to solve this. A question, and this is worth about 6 marks in exams, the one that I just worked out. All right, so solve. I'm giving you 2. The first one is 4 to the power x is equal to 5 to the power x plus 1. And the second one, 3 to the power 2x plus 1 is equal to 2 to the power x minus 2. Right? Solve each of them. I'll give you 6 minutes. Right? Go ahead. We'll correct it. If you have questions, I'm right here. Is anyone finished with number 1?
Yeah.
Yeah, sir.
Okay, so I'm going to start working on question 1, right? So for question 1, the first thing you do is you apply logs. So you'll get log 4 to the x is equal to log 5 x plus 1. Then you use the rules of logs. You'll get x log 4 is equal to x plus 1 log 5. Right, I am removing the brackets now. I'll get x log 5 plus log 5. And this side I'll get x log 4. So I'm bringing all the logs on the same side. I'll get x log 4 minus x log 5 is equal to log 5. And then finally, factor of the x, you'll get log 4 minus log 5 is equal to log 5. So you'll get x is equal to log 5 minus all over log 4 minus log 5. Did you all get that?
Yes, sir.
Sir.
Yes, sir.
Okay, great. Anyone has any questions before I move on to the second one? You all are doing excellent work. I'm really proud of you guys. You guys are doing great for a first attempt at logs. Any questions?
So if you had like 1 log 5 instead of just log 5.
No, that's perfect. You know, that's no problem. You mean if you put a 1 here?
By the log 5.
Yeah, that's no issue at all.
Yeah.
One log 5 is log 5. So that's no problem.
Okay. Thank you.
All right, so let's do the second one now. Right, question 2. If you take logs of both sides, you're gonna get this. Then you apply the rules of logs, you'll get 2x plus 1 log 3 and x minus 2. Right, sorry about that, guys. So you'll get x minus 2 log 2. So let's remove the brackets now. You'll get 2x times log 3. And then 1 times log 3. And then you'll get x times log 2. And then minus 2 times log 2. Right now, what you do at this stage, everybody, is you bring the terms in x on the same side, right? So I'm going to take this on the opposite side there, and I'm going to bring this term on the left side. So just follow the arrows. You'll get 2x log 3 minus x log 2 is equal to minus 2 log 2 minus log 3. And now I factor out the x, so I'll get x into 2 log 3 minus log 2 is equal to minus 2 log 2 minus log 3. And the last step is this. I have x multiply by all of this here. So if I'm multiplying and I carry this across, so instead of multiply, I'll have to divide now. So I have minus 2 log 2 minus log 3 all over 2 log 3 minus log 2. Anybody got it?
Yes, sir.
I was a
Yes,
bit
sir.
unsure, but yes, I did get it.
Yes, sir.
Great. Any questions with number 2? Anybody? Look at it, see if you all have any questions. As I said, you all are doing excellently. For the first time doing logs, you all are doing excellently so far. Any questions? None so far. Okay, great. All right, so just hold on one, guys. I'm seeing a student trying to call me. Just hold on 1 second. Again, so let's move on. So we finish with this part for now. I mean, we have a lot of practice to do. I'll give you a lot of questions to practice, right? Because that's the only way you'll get really good at the thing. So I want you all to do a lot of practice. But for now, I want to move on to something else. Let me see. Here, solving log equations is what I'm looking at now. Okay, these are all exponential as well. Right, everyone. I just forwarded to your WhatsApp a document, a PDF document on logs. Right? It's on your WhatsApp. Can you all confirm being able to access it? It's on your WhatsApp right now.
Yes, sir.
Yes, sir.
Okay, great. So here what, guys, instead of putting this on eClassroom too, this is just additional exercises right here. Here what we're going to do, we're going to do question 7. 7 has 8 parts. Look at it. You'll see there's part 1, part 2, part 3, part 4. The only thing I didn't teach you so far in logs is you see where you see the letter E and LN. I'll leave that for last. It's quite simple. It's the same rules, everything. It's just I don't want to confuse you too much by giving you too many things all at once, right? So far, you all are doing really well. In our final exam, you all can maybe do, you all could probably get more than 10 marks already in the final exam, right? You all are doing really well. So in question 7, I want to do parts 3, 5, and 7. And I want to have you all do parts probably 2, 4, 6, 8, and we'll correct it. And that's where we'll close off today's class. And the next session, we will look at applications of logs. There's financial work we need to do with logs, in particular, continuous compounding as it applies to interest, like with bank loans, etc. And we need to do exponential growth and exponential P, right? Those 3 examples we'll be doing next class. But I want to go through some of these with you and have you all getting sufficient practice, right? So let's enter a new session and let's get some more work done.